Hi, everybody from Mary Baldwin College, taking the Psychology Statistics class. This is Dr. Tausman, or Julie, your cruise director, for those of you who used to watch The Love Boat in the 80s. Okay, so I'm a little old, what can I say? I'm going to share with you the statistical lessons for week one here. Your job, as it says on the agenda, is to type out good notes, write the information down, and then try to do the homework problems. If you want to send me a draft, you certainly can. A draft or two, and I'll work with you that way. And then at the end of the week on, what did I put on here? Sunday, or by Monday, is to post the final file for class by Monday evening. So let's start with the main question of the day. You're all taking statistics here, so let's just say, for the sake of example, that I, as a researcher, I am curious if students have this made-up term called statisticophobia, right? Fear of statistics, which certainly some people do. So let's just say, for the sake of example, I come in to a class that has 100 people, and let's say that I ask people to raise their hands, and 90 people raised their hands and said they're scared, and 10 people raise their hand and say they're not scared. Of course, the 10 people may have brain damage, but hopefully not. Okay, that's my weird sense of humor. So in this first example, let's just say that 90 are scared and 10 are not. What we try to do as researchers is we want to figure out, is this data indicative of most of the students having statisticophobia, and is this a statistically significant difference? Which we'll get to a little bit later. So 90 versus 10. Now, what do you just think of that? If it's 90 versus 10, you'd probably argue, yeah, and it's 90% of the sample is saying they do have statisticophobia, and that's a lot of people, so you'd probably say yes. Well, the way we evaluate this is we do a statistic that's featured in Chapter 17 of your book called a chi-square. Chi-square, it's in Chapter 17 of your book, and it's called a chi-square goodness of fit. And we have an exciting little formula that I put down on the agenda. FO minus FE quantity squared over FE. And that little E thing is a summation sign. So that is the formula we use. FO stands for frequency observed, and FE stands for frequency expected due to chance. So let's just play around with this a little bit and see what we can figure out. What is the frequency observed? Well, in our data set, we have two observed frequencies. One frequency of the sample we used was 90 people were scared. So one FO is 90. A second FO is 10. Now, the second part, FE, frequency expected due to chance. What do you think the frequency expected due to chance would be? Well, you look at the total number of the sample here, 90 and 10. What's that total number? It's 100. And if we sampled 100 people and we got results due to chance, what would those results be? Well, 100 people, two categories. Chance, hopefully you would be able to figure out, chance would actually be 50-50. So chance would be a score of 50. So what we basically need to do is plug those numbers in, and I tried to do that below to just show you how it would work. The sum, which is kind of the E symbol, of what's the first FO? 90 minus FE, 50. You square it, and then you do the second part of that formula, the number 10. 10 minus 50 squared, and you add all of that up, because you sum it first, and then you divide that by 50. Or you could divide each one alone by 50 first, and add it up. It would be the same thing. So if you do the math on that and try to have a calculator, you can certainly use calculators in this class and figure things out. What you would get at the end is 1600 plus 1600 over 50. And so that's going to be 3200 over 50. And if you do that division out, you will get a Beatles song. What is the Beatles song? When I'm 64. As it turns out, 64 is also the year I was born. And just to share a little more detail with you, definitely don't write this in your notes. It turned out I was born in February of 64, and it was only a month after the Beatles first came to America. So my mom was in her third trimester, bless her heart, so any brain damage that I might have or any peculiarities in my sense of humor might be due to the fact that my mom was probably stressed out with the Beatles coming to town, and of course it was only 3 months after Kennedy was shot, so that could explain some of my unique neurobiology, ha ha ha, for the class. So hopefully you were able to figure out that the result here was 3200 over 50, or 64. So we get a chi-square obtained, we call that, of 64. So the next question that we have to figure out is whether or not a 64 is a significant difference. So the way we do that is we have to look in the back of the book, page 711. They actually give you a chi-square table, and I'm not going to go into a ton of details here, but what you have to do is you have to look at 0.05, and you have to look at degrees of freedom 1, because there were two categories here. You get a chi value of 3.84. Can you find that chi value, 3.84? The big issue is our chi obtained bigger than that chi critical score? And in this case, a 64 is definitely bigger than that. So the result is you have statistical significance. The result is you have statistical significance. The real world meaning is that the results basically show that a significant number of students do have what? Statisticsophobia. So that is the key result here. If you want to write this out in an APA way, in E, I kind of showed you the results for that. You write the symbol chi-square, which you can see in chapter 17, the x squared, df. df stands for degrees of freedom, and if you have two categories, you have 1 degree of freedom, so it would be chi, and then in parentheses 1, comma, n. What is our total sample size? N equals 100. And then you would write the chi obtained value, which is, what did we say, 64. And then you would write p less than 0.05. And you would say in the real world that there is a statistically significant difference. People are scared. So hopefully you can do and write that out. I put in F there, what if 51 people were scared and 41 were not? You could do the computations on that. You wouldn't really necessarily need to, because it was 51 and 49. Your chi value would be very, very tiny if you did the computation in C. You get a value no larger than, 0.5 or 1, and then the chi obtained value would not be greater than 3.84, and your result would not be statistically significant. 51 and 49 are pretty close to chance, 50, so that would be the way. So hopefully this makes sense. Homework problem 5 on page 627 of chapter 17 will let me see if you can figure this out. Take good notes on this. Try to listen to this more than once if you need to, and hopefully you can figure this out. Thank you. Bye-bye.